So I have a bit of a history on Quadra Island. I did part of my carpentry apprenticeship here, and even though I'm abroad now in Germany, Andreas and Danielle from Study Build contacted me because they have this amazing opportunity on this piece of land we're standing in to create a bit of a housing initiative or to move forward to create something here. And he said, I'd like to know maybe how a carpenter like you, who's from this area, who knows the narrative of the region, how you would go about doing this. And so I've been putting my best effort into just being myself and approaching this from a very practical standpoint. My task was fairly clearly defined: to think about a style of building that's familiar to people here on the coast. When you look at this, it should look simple, because it should be simple. So to develop a style of building that we can build on the coast, and you'll see here that we use, for example, this diagonal shiplap, which you'll see in buildings from the 50s, 40s, and up to that point until the advent of panel-based materials like plywood. So the challenge was, and there always should be a nice challenge, is can we build without this? So that's what I incorporated into my design. So what we're looking at is an exterior corner of a building, a section from a floor system up through the roof. And one of the most interesting things about this model and about this design is how the membranes, how the airtightness, or how the airtight layer is run. Because in a passive house, you guys familiar with the term passive house? Have you heard it before? So it's a energetic requirement, or an energetic standard that you can reach in buildings. It was developed in Germany. There's no surprise that I found it there. But it requires an extremely low amount of energy to maintain the energy and heat in these buildings. Because through conditioning of the air and through really low levels of heat transmission towards the outside. So that's why you're looking at this. This is about 44 centimeters, or I can't remember what that is in inches, but about 44 centimeters, and there's still a facade which comes on the outside of this. But this is the structural layer. So this is a shear wall. The airtight layer runs between my shear wall and I call this like a down jacket. This is a second wall that attaches to the outside of the building, and this is insulated as well. And one of the insulation materials we've been looking at, among many, there are many choices, is cellulose, which is a material that's made of recycled newspaper, has excellent thermal values, and is abundant, and people have experience with it here. Because I don't want to show up with a design with a material that people aren't familiar with, because that's just pre-programmed failure. People are skeptical. So I tried to keep it as simple as possible. So this is a modular construction, not modular in the sense of we build entire rooms and then deliver, but modular in the sense of prefabricated. So you'll have wall elements that could be up to full length, could be 12, 15 meters long, and you produce them on a flat table in front of you. So if you imagine, instead of putting on your sheathing and your siding and whatever else in your electrical installations, you have a wall laying in front of you. And so you lay out your studs and you produce that wall at about this height. You can move around it. And once you're done, once you have your drywall or your gypsum board, you have your windows installed. If you want to go to that level of prefabrication, you can do that. Then you store them, and then they're delivered onto the construction site and installed with a crane. Where a large part of the industry is moving in Germany, at least in wood construction, is towards pre-manufacturing and prefabrication of elements. Because what that does, and we have a great example here today, this is inclement weather, right? So a lot of the construction sites just stop, or they're really affected by situations like this. So what you do when you prefabricate construction is you can move yourself into a nice conditioned facility, or at least have a nice covered space, which allows you to produce in any weather. So that means that we don't get these real swings throughout the year of the seasons where we really slow down, the seasons we speed up, this big summer rush. So prefabrication, I see that as a way of giving more people work all year. And the nice thing is, if you don't have people working up on roofs, as we do traditionally in stick building, we can bring seasoned veterans or seasoned carpenters that maybe wouldn't feel comfortable with that, we could bring them back in to these workspaces to work, you know, in a safe environment and not up on the slippery roofs that you would have today. So those are some reasons for prefabrication. This system you might have seen on the drawings here. It works on a standard raster of always 2.5 meters. So this is difficult for me to design buildings because I've always received the plans and I've always executed the plans. So this is, for me, for the first time, I think, probably a quite, I wouldn't say rudimentary, but a very easy, a very legible design. Because I know, as a builder, that I can build that using this design. So we have the possibility, we were talking to Johnny Marlowe in the woodlot today, we have the possibility of using, absolutely, wood from our region, wood from our island if we want. So the only wood materials, secondary materials, so they've been processed somewhere that we have, are in this floor system. And that's for reasons of weight bearing and loading. So while you guys were out doing all kinds of wonderful things this week, and I got to do some of them with you, but it feels like most nights I was up here occasionally with some good help working on this, just to see if what I had envisioned in my mind was possible. And one of my goals is that people who want to come, electricians or plumbers or HVAC, can come and look at this and say, okay, with this system we can run our installations in this way, or even have suggestions about how we could do it better. So this is kind of a dry run, or a trial run, if you will. This system which we have here, so this ladder system, is exactly the same as this one up here. It's the same detail, it's just brought into that plane. And this airtight layer runs up here and then runs over the top of this mass timber roof, which you can have a look at here if you like.
What's that material, the airtight?
So the airtight material here is a polyethylene foil.
Okay, so that's what runs up.
Yeah, that runs continuously. So my exterior walls, when I deliver them on the construction site, they have an extra 2 feet of material. And so they can be tied onto here, taped onto here. So you always have to leave that extra bit so that during the construction, during the montage, you tape these seams. So you need that really high level of airtightness in passive houses. Because they are very efficient, you don't need to heat them that much. And to be able to have that level of energy efficiency, you have to really condition the air. And they're filtered, they go through a HEPA filter, and people living in cities are actually kind of a target group because of the air quality issues surrounding living in cities. People with allergies, and just a very comfortable building to live in. So there's, lots of documentation. There's, I don't know how many thousand buildings worldwide.
So you set up a mechanical ventilation system?
Absolutely, yeah. So with heat recovery systems. So the structure that maintains the same idea as our exterior wall. This first layer is our structural layer, and the reason I've done that is I can have an almost uninterrupted air barrier that runs up here, and you can see it would make this corner right here and continue in there. So I've got the least possible perforations in it, and that's really the crux of the whole design. This was nice, or this was fun to play with this guy because it is structural, but it is also aesthetic. So when you move in, it's your finished surface. That's what you see right away. And that's one of the benefits of mass timber, is that you often have what they call your raw construction, or as soon as you move in, that's it. So you need to protect that surface, but if you're like me, it's just a very comfortable atmosphere to live in. But typically, we would have what we call a 2x6 exterior wall in nearly all of our buildings. And this layer, this polyethylene layer, or this whatever product you use, would be moved on this side of the studs. So right away, you're fastening all of your drywall or whatever surface you have through that. And then
so
you're perforating it. And people do often say that those perforations, because they're tight, they're sealed again. But I don't believe that. Not in every case, having built here myself. So that's one of the major differences And I said the crux of the design is moving this outwards of the structure itself. When I kind of dug down deep, I realized when somebody asks me in 30 years, or somebody asks me, if it's 30 years down the road from now, I want maybe people, when they talk about how we build here and how we build for climate change and how we build for the future, I want maybe some of the buildings that I've designed or some of the systems that I've designed to be part of that narrative. You know, when people think about the time, they say, well, you know, maybe what he did fit really well at this time, you know, a well-designed system.